All right, so let's look at sundials on a globe. So what I did here is I'm still learning Blender and I'm still trying to figure out things, watching some tutorials and all that. But I think I've got it figured out. So what we have here is we have a sphere that's not perfect. It's at 127 by, and then 126 makes it the size of the Earth as the, slightly oblate spheroid. And then what I ended up doing is now I'm on the 35th parallel. So what I ended up doing is creating a compass, or not a compass, excuse me, a sundial with all of the angles to match. So what I did to do that is you can actually find some sundial calculators online, and it will tell you what angle each one of these lines need to be at. So 6 o'clock, 7, 8, 9, 10, 11, and then 12 o'clock, 1, 2, 3, 4, 5, and 6. So this is a 12-hour sundial, 6 to 6. It's a horizontal sundial with a gnomon that's at 35 degrees elevation, because I'm at the 35th degree latitude. And so what I have to do is I just have to place it right in the middle of the 35th degree parallel, or latitude. And then what I have to do is basically set it flat on the Earth, the spherical Earth, and then that makes this 35 degrees off of this tangent. Okay, so this is your gnomon, 35 degrees. It matches the latitude position, so that what that does is it basically makes it point straight up, like it would be pointing at Polaris in all intents purposes. So here's what we got here. So we've got a little bit of shadow. We've got the sun pointing at this Earth, and it's at 12 o'clock solar noon time, right? So what we're going to do here is we're going to just do some simple movement of the Earth and see what happens. So right now I'm going to go and rotate on my Z-axis. It's 15 degrees every hour. So if I hit 15, what that's going to do is that's going to rotate this sphere. And you see this is the originating point right here. It's going to rotate that sphere 15 degrees. So now if we pull back and we look at the it over here, so this is 15 degrees from this position. So when you look at the shadow, it's at 1 o'clock. So that's pretty neat. So if we moved it at 30 degrees, now the ball spun 30 degrees, and now we're going to look at the shadow, and now it's at 2 o'clock. Now if we do, again, this is showing a 30-degree rotation on the Z. And then if we do it at 45, let's go to 45. All right, let's go 45 here, right there. And then we'll look at it again. So you can see the originating position here. That's where it starts. This is 45 degrees away, and then you can actually verify this by looking at it from a top-down view, right? So there it is right there. That's a 45-degree angle. And so this is 45 degrees, and if you scroll in and you look at it, holy crap, the line's at 3 o'clock. So, right there, so 12, 1, 2, 3. So far so good. We're going to rotate it now at 60 degrees. And now it's at 1, 2, 3, 4 o'clock. The shadow's at 4 o'clock. And that's kind of hard to see because of the rendering, but it's kind of spacing out a bit. But if I do this, you can kind of see where it's going, but it's at 4 o'clock. So let's do 75 degrees would be 7 right there. And probably, there we go. So as you can see there, it's now at 5 o'clock. You can kind of see the shadow changing between there as it gets further and further away. I may have to change the intensity of the light because I have the light at pretty low strength. So I changed it to 4, maybe bring it up a little bit, maybe to 5. So anyway, so we see when we rotate this object, we'll go back to 0, that it matches. So as long as we have the gnomon at the correct latitude position, it's going to work just fine. So okay, well, what happens if this ball is, it's completely up and down? So what happens when we angle it out? So let's check it out. put it on a 23.5 degree tilt and see what happens. All right, so let's try to make this as best as I can, as most realistic as I could on this one. So now we have a 23.5 degree tilt sphere, and we have the sundial at the 35 degree mark. And so we're going to rotate this Earth 15 degrees. All right, so there's a 15 degree rotation down there. Now if we go and we look at it, we are seeing that the shadow is at 1 o'clock. So now if we add another 15 degree rotation, now the shadow is showing at 2 o'clock. Another 15 degree rotation. Shadow is now showing at 3 o'clock. And another 15 degree rotation. Now the sun is showing at 4 o'clock. So there's 12, 1, 2, 3, 4. So there's a 4 o'clock. And if we did another 15 degree rotation, ooh, it's looking at 5 o'clock. So from this position, I'm not 100% sure. I think this is December 21st. So we're starting to not be able to get a shadow in this position. And as a quick check, we're December 21st from my location. December 21st. Sunset is 4:58 p.m. So let's take a look at that again. So when we said we're looking at 5 o'clock, this would be our 5 o'clock time, we're having sunset. So yeah, that matches up perfectly. So let's go back to, let's make this back at our starting position. And we can actually do it in the other direction if we wanted to as well. So let's go back to, let's say 10, that'd be 360, 350, 345, I think. 345, 15 degrees. And as we see here, is my math wrong? Hold on, 345, 355, 360. Ooh, wait, hold on. My math is not mathing. Let's see, hold on. There we go. I went 10 more degrees over. So there is your 11 o'clock. So let's go 355, 345, 340. Let's go to 340. There's another 15 degrees. Ooh. And there it is at 10 o'clock. Go back another 15 degrees, which should be, for this one, be, I'm having to do the math backwards here. So that's another 15 degrees. And now that is showing, was it 6, 7, 8, 9 o'clock? 10, 11, 12. Yep. So it works. It's pretty neat. This just an example of how a sundial works on a spherical Earth. You're just going to make sure your gnomon is matching the latitude that you're at, and yeah, it works just fine. So I'm gonna keep playing with this a little bit more, trying to test out different other elevations, but you got to remember that these radial angles here are specific to latitude, so you've got to figure out all that good stuff.